What up, everybody? InstructaBeats back again. Today we are talking about what is an improper fraction. Don't look at me, I'm hideous. It's improper. That's just a line from one of my favorite movies, Harry Potter. So let's split it up and see what our objective is today. All right, our objective today I will be able to recognize improper fractions when looking at area models and number lines. All right, let's review what we did last lesson. If you didn't do last lesson, check that one out if you're not sure what a fraction is. But here we have a proper fraction that's just 3/4, right? And so we know our denominator is 4. And what we want to do is we want to represent this on our area model and also a number line. I like to do the area model on top of the number line because sometimes number lines get tricky for me. But if I visualize it like an area model, it makes it a little bit easier. So my denominator, or down the bottom part of my fraction, tells me I need 4 equal groups. So I know fractions again are equal groups, or as equal as I can make them because I'm not always the neatest. But I'm going to split my area model into 4 equal groups, and I'm going to recognize that this area model is equal to 1. So I put the total over here. I'm going to make sure I do the same thing for my number line. This is equal to 1 whole, this number line. And just like I split the area model, I'm going to split it up into half, split each of those into halves, split this part into half, and now I have 4 equal groups. And now I know my numerator was 3, which tells me I need to shade in 3 of these pieces. Now, I'm going to do the same thing on the number line. I start at 0, and I'm going to count over 1 space, 2 space, 3 spaces, and I'm going to shade those in. And I actually like to I like to label my area model as well. So let me go ahead and do that. I have 0, I have 1/4, 2/4, which would also be equal to 1/2, 3/4, and this is 1 whole or 4 out of 4 because 4/4 is equal to 1 whole. So that's what we learned last lesson, right? That's just a quick review. But what if there is more than 1 whole, right? 3/4, that was just 1 brownie. We split up into 4 pieces. I ate 3 of them. But what if I have more than 1 brownie? That's what our mathcabulary answers today. An improper fraction is a fraction that is bigger than 1. Okay, and when you look at it, you'll notice the numerator is bigger than the denominator, and that's what a lot of people focus on when they teach improper fractions. But really, an improper fraction is a fraction that is bigger than 1. Let's take a look at what I mean by this. So here we have an improper fraction 6/4. I recognize it's an improper fraction because the numerator is bigger than the denominator. But really what that means is 6/4 is bigger than 1. Let's take a look at what I mean, right? So here, my denominator is 4, okay? That means each whole is going to be split up into 4 equal groups, all right? Because here I have 0 to 1, okay? And then from here I'd have 1 to 2. So let's focus on the area models for a second. Here we have 2 whole brownies, and I'm going to split each of them into 4, okay? Now, some of you would think, wait a minute. If I split each of them into half, I now have 4 pieces. But again, that's not the definition of a denominator. A denominator tells us how many each whole is split into. So this brownie needs to be split into 4 equal groups. And this brownie also needs to be split into 4 equal groups. Hopefully you draw your lines straighter than I do. All right. Now, that's my denominator. Each brownie I've now cut into 4 equal groups. And then you know what? I ate 6 of those pieces because I was hungry. So I have 1. I've been trying to lose weight. And you know, when you're trying to lose weight, you get hungry. So that's 4, but I needed to eat 6 of those pieces. So I needed to shade over. So if you look at this, I ate 1 whole brownie and then another 2 pieces. I ate 1, 2, 3, 4, 5, 6. And my denominator is 4 because each brownie was split into 4ths. Now let's show this on a number line, right? So again, each whole, so each of my wholes is going to be split into 4ths, which means I need to split them into half and then split each of those into half. And you see that this would be 1/4, 2/4, 3/4. If I ate 1 whole, that would have been 4 out of 4 pieces. My next one is going to be 5/4, 6/4, 7/4, 2 wholes, or I could do 8 out of 4. So you see when I put them together, I now have more than a whole. So 6/4 is an improper fraction because when I shaded it in, it was more than just 1 of my brownies. I had to go into my next brownie to finish the rest of the pieces. So an improper fraction is a fraction that represents more than 1 whole, and it also can be recognized because the numerator will be bigger than the denominator. because I'm not just going to eat 4 out of 4. I'm going to eat more than that. That's why my numerator has to be bigger. Here's your key thought, okay? It's very, very important you recognize this. Your denominator does not tell you how many total equal pieces. If we go back, we had 8 total pieces when we were talking about those 2 brownies or area models, however you want to picture them. I like to picture food because I understand food, okay? Your denominator tells you how many equal pieces are in one whole. So I had 4 in one whole. That's why my denominator was 4. I had 4 in the other whole. That's why my denominator was 4. That's going to be your key thought. That's going to be very important to you. All right, so it says what fraction is represented by this area model, okay? So first of all, I see right here that I have an area model and I have a number line. I'm showing them together. And what I like to do for my number lines is I'm going to circle my whole numbers. And the reason I circle my whole numbers is that way it helps me figure out what my denominator is. When I'm looking, let me get my highlighter. When I'm looking to figure out my denominator, I'm only looking at one whole, okay? I'm not looking at all of my brownies or my whole number line together. I'm only looking between 0 and 1 on my number line because my denominator is how many pieces each whole or one whole is split into. So for this, I see on my area model and my number line, I had 2 equal groups. So my denominator for this improper fraction is 2. Now I need to know my numerator. So how many total pieces were shaded, right? So I had 1, 2, 3, 4, 5, 6, 7. So the fraction that is represented by this area model is 7 halves, or 7 over 2. Each of my brownies, if I picture them as brownies or area models, if you will, were split into 2 pieces. And then my numerator, I shaded in 7 of them. I'm also showing you 7 halves on my number line because each whole number is split into 2 equal groups. And then I shaded in 1, 2, 3, 4, 5, 6, oops, missed it, 6, 7. So if I labeled this would be 1 half, this would be 1 whole or 2 halves, this would be 3 halves, this would be 2 wholes or 6 halves. That would be 4 halves, I can't even count today. Here would be 5 halves, here would be 3 wholes or 6 halves, and then this one would be 7 halves or 7 over 2. So figuring out your denominator first, then going back and looking at your numerator. All right, so our we do problem, what fraction is represented by this area model? So again, I only want to look, let me get my highlighter, at one whole right here, okay? So whether it's an area model or the number line, I only want to look at one whole. What helps me do that is by circling my whole numbers on the number line. Because a lot of people would come to this number line or come to this area model and you think your denominator is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 because you had 12 total pieces. But remember, your denominator is how many one whole or each whole is split into. I see right here in my number line that I have 1, 2, 3 pieces. So my denominator has to be 3. This whole is also split into 1, 2, 3 pieces. This one is also split into 1, 2, 3 pieces. And so is this one. So my denominator is 3. Now I want to look at my numerator. So how many pieces are shaded? All right. So again, I like to think about food. So I have 1, 2, 3, 4 brownies total, right? And I split each brownie into 3. That's why my denominator is 3. And I shaded in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces. So my improper fraction that's represented is 11 thirds. What does it mean? It means I had more than one whole shaded in, and I recognize it's improper because my numerator is bigger than my denominator. I have more pieces shaded in than I had my one whole split into. And again, it's the same thing for your number line. So here's 0. This would be 1 third, 2 thirds, 1 whole or 3 thirds, 4 thirds, 5 thirds. There we go. 2 wholes or 6 thirds. This would be 7 thirds, 8 thirds, 3 thirds or 9 thirds, 10 thirds, and 11 thirds. So no matter if you show it on an area model or a number line, you still get 11 thirds for this fraction. All right, so we have one you-try problem, and I've changed the area model from a rectangle to a circle. So if you're thinking food, from a Hershey bar to a pizza, okay? So what I want you to do is pause the video. Let me move this InstructaBeats logo out of the way, okay? And you're gonna figure out what fraction is represented by this area model. So start with your denominator, right? Count how many pieces one whole split into, then count your numerator. Hopefully you just tried this out. So I'm gonna go ahead, I'm gonna write my denominator first. So if I'm using my area model, then I can check my number line as well. I see 1, 2, 3, 4, 5, 6 pieces for each of my holes. And then if I circle my hole numbers, and then I circle my hole numbers so I don't get confused, that means I can really focus on just this one hole right here. I have 1, 2, 3, 4, 5, 6 total pieces. So my denominator is 6. I'm just checking it. Now I want to find my numerator, right? How many pieces are shaded? So I know that I have 1, 2, 3, 4, 5, 6 in this one. So I could count by ones, or I could do 6 plus 6 is 12, 13, 14, 15. So my improper fraction for this would be 15/6. What this again tells me is each hole was split into 6 pieces, and then I shaded in 15 total pieces. And again, it's the same thing down here for this number line. Hopefully this gave you a good introduction to improper fractions and what they look like on an area model and number line. Check us out next lesson for mixed numbers, which are very much the same thing as improper fractions, just a different way to write it to represent the same value. Thank you again. We hope that you'll like, comment, subscribe if you haven't joined the InstructaBeats family. We appreciate you. Thank you so much. InstructaBeats out.